Now we will move to machine learning models. Once the pre-processing is done, your data is ready for a model to be built on it. To train an ML model, we need to decide a machine learning algorithm so that the algorithm can learn patterns from the data. This model is then used to predict the target attribute on unseen data. AML does not have a large variety of machine learning algorithms that it supports, but it is sufficient for some basic problems to be solved. This is one reason it is not suggested by data scientists when you want to use complex algorithms or a mixture of algorithms. However, it is encouraged by a lot of companies when they want answers to some simple questions without the use of data scientists. The problems that can be solved are binary classification, multi-class classification, and regression. There are only a limited number of learning algorithms that you can use. The learning algorithms that it uses for each type of problem are: for binary classification, it uses logistic regression. For multi-class classification, it uses multinomial logistic regression. For regression problems, it uses linear regression. The optimization technique is stochastic gradient descent. I am not going to go deep into how SGD works, but for an overview, SGD updates the feature weights at each step so that the loss function is minimized and the learning algorithm is trained at its optimum. So, as you know, to make a machine learning model efficient, it is required that we tweak the algorithm's hyperparameters to reach the most efficient solution and increase the quality of our model. Most of these hyperparameters are preset in AML and you have little control in changing that. But it's important that we know the default values in order to understand the output of our model. Some of the training parameters or hyperparameters that AML supports are: first is the learning rate. Learning rate is auto-selected based on our data and fed to the stochastic gradient descent function. The second is the model size. Model size can be changed up to 100 MB, which is the default value. If you keep your model size to be too small, AML might not be able to read all the patterns from your data. If your size is bigger than 100 MB, AML will fit it to 100 MB and would not. AML makes a number of passes over your data to discover patterns. AML makes at a default 10 passes, but you can change these passes to a maximum of 100 passes. If AML is not able to read a new pattern after certain iteration, it stops even if you have specified for it to take more pass. Another training parameter is shuffle type. Shuffle type is also the parameter we can change. We have discussed about this while we were discussing about splitting our data, and it's the same as it was there. If you want to shuffle your data, you make the shuffle type to random and none otherwise. Next is regularization type. I again wouldn't go deep into what regularization is all about, but it is an important metric that is added when a model is suffering from overfitting of data. AML provides L1 and L2 regularization, both of whose value can be adjusted using the regularization amount parameter. By default, AML uses L2 regularization with some default amount. Now, how to create the ML model? Amazon allows you to create your ML model using two ways. First is when you create it with the default options, and second, AML gives you the freedom of customizing your training parameters. That is called the custom option. With the default option selected, AML trains the models on all the default values that we have discussed till now. After creating your model, another important task is to evaluate the accuracy of a model. A high accuracy model can be then used for predicting new data. If we don't achieve the required accuracy, we would want to go back and tweak our training parameters. AML provides quite a few metrics to evaluate accuracy. These metrics are selected automatically by AML depending on the type of the problem. For a binary classification, the algorithm outputs a prediction score. The observation is assigned a class based on a cutoff value. The default cutoff is 0.5 if score is greater than 0.5. The class assigned is 1 and 0 otherwise. The default cutoff value can be changed and the results can be reviewed on the console page. After the classes are assigned, AML gives an accuracy score of the values using AUC metric. There are other metrics as well which Amazon uses, such as accuracy, precision, recall, and so on. To set a threshold, we use the adjust score threshold on the console. For multi-class classification also, AML gives a set of prediction score for each class for an observation. There is no cutoff value as such. The class whose score is maximum is then considered to be the predicted class. Say for example, if I am classifying into 0, 1, 2 as the classes, and if the score for class 0 is 0.2, 1 is 0.7, and for 2 is 0.1, then the class assigned to my observation would be 1, as it has the higher score of zero point 0.7 as compared to others. For multi-class classification, F-score is used as the evaluation metric. Also, a confusion matrix is generated for the user to view the decisions that the model has taken, if it has assigned it the right class or any other class, which is the wrong class. For regression models, the value generated is the actual value of the target, and the evaluation is done based on RMSE, which is root mean square error. Root mean square error is calculated as actual target minus predicted value whole square divided by the total number of observations that you have. The residuals, which is the difference between actual and the predicted value, are checked to understand what are the values the model was not able to predict correctly. AML also allows you to run k-fold cross validation if you want a better evaluation on your dataset. A very good feature about AML is the evaluation alert feature. This is pretty useful as most data scientists tend to not notice the minor mistakes while building models. AML has a really strong way of identifying if your model didn't perform as expected. AML console gives the step name if there was an issue with evaluation. Amazon ML alerts if you use the same data source for training and evaluation. Another point it gives is that if the number of observations in your evaluation data is less than 10% of the number of observations you have in your training data source, it will give you an alert. If the schema for the training and evaluation data source are not the same, then also AML will point out. If some records in the evaluation data source were invalid and were not included in the accuracy metric computation, Amazon will let you know and you can then change your data source or correct your data. If the distribution of target variable doesn't match, like we discussed, if we have some categories which are available in training data and those categories are not available in test data, AML will ask you to either reset your data or reshuffle your data. You can choose whatever you want to do and go to the previous steps and correct it. Now, the final step is generating predictions. AML provides two ways of prediction from the model build. As we have discussed before, we have the batch and real-time predictions available. We will discuss how to build a batch prediction from console. On the Amazon ML dashboard under Objects, you need to choose create new and then choose batch prediction. Choose the Amazon ML model that you want to use to create the batch prediction. To confirm that you want to use this model, choose continue. Choose the data source that you want to create predictions for. The data source must have the same schema as your model, although it doesn't need to include the target variable. The fifth step is you choose continue. For S3 destination, type the name of your S3 bucket. We need the S3 destination because whatever predictions are going to be created would be moved on to the S3 bucket, as you won't be able to view the batch predictions until and unless the whole model finishes running. Once it's finished, sets are done, you need to choose review. Review your settings and choose create batch predictions. Now the predictions are created in an S3 bucket. You can check the predictions created by going into the particular folder. For checking if your batch prediction was correct or not, you can review it by checking two tabs provided by AML. AML gives a tab of records seen, which is the number of records processed while generating the predictions, and records failed to process, which is the number of records that AML failed to process. As I said, the predictions that are created are sent to an S3 bucket. For reading the location of the S3 bucket folder, you can find it in the .manifest file, which will be created once the batch prediction finishes in the same S3 bucket location. You can use these predictions created for future use. Also, once a model is created, you can use it repeatedly with different datasets by using either batch predictions or real-time predictions as well.